We're not going to learn how to program on Arduino today. That might be overshooting the mark. What we will do, though, is we'll use some programs that have already been created by other people, and we'll go over some basic ideas of electronics, circuitry, and then show you where most people begin when they start doing programming with Arduino. Now, if your computer didn't work, that's okay. What you can do is you can download the library from someone else, and then you'll still be able to do the physical computing part with the development board, which is that white breadboard that you have. So does everybody have their black Arduino board mounted? Let me see thumbs up if you have your black Arduino board mounted. Good. So there's two sides of this Arduino board. There's the actual development board, which if you look on it, it's called a red board. That's just an Arduino. It's a SparkFun version of Arduino. Nice. If you have that, then the other side, it's got a white plate, and it's just got a bunch of little holes in it. That is called a solderless breadboard. And the reason why they call it a breadboard was in the earliest days when electricity was being kind of worked on, they used nails in cutting blocks that were used for bread. So they drove nails into these, and they would wrap wire around these nails. And that's how people were kind of doing inventions with electricity, you know, in early 1900s. So that's where the name breadboard came from. And so now they just kind of stuck with it and they use it. But all those are is just a bunch of little holes and pins. And if you push the pins into them, then you can actually make connections. Instead of using tape or spinning with your hands, you push a little metal probe into those, and it will connect it. It'll make that wire conductive with something else. It'll make the connection. So it's nice for development. What I want to do today, and what I plan on doing with you guys for the next hour, 2 hours with you, is let's go through a couple of these examples in the book that they have. And they're lessons. There's like 16 of these lessons. What we'll do is we'll start with one, and I'm going to walk around and kind of talk with people, but it really is going to be what you make of this. If you have intentions on learning how to set up these programs and go through as many of them as you can, my recommendation would be is to get a good understanding of at least the first 5, 6 lessons that they have in the book. Because what you would do with these is then your kids that come in after school, or the kids that finish their assignments early, or whatever you have, just put this in the back of the room somewhere and let them go through lesson 1, lesson 2, lesson 3. It's low entry, but the amount of stuff that you can do with this is amazing. I can get on the internet and show you guys in a little bit. If you can learn how to operate one LED, then the next step is to put a strand of LEDs together and create like musically timed Christmas lights or anything else. So there's a lot of things that you can do with this. So what I want to do is kind of show you where we can start off with. And this is really going to be self-directed for the next couple hours. So let me begin by saying, have you downloaded the SparkFun Inventors Kit library? You'll need that downloaded. Now, there's some steps where you can actually upload it to your own Arduino. And so that way you can go into, if I just go into Arduino really quickly, let me show you. With my Arduino open, if you learn how to install that SparkFun library, you should be able to go into File and like Sketch or even Examples, and you should be able to find the SICK guide code, and it has all of these 16 different examples of circuitry. Now, I'm not going to take any more time trying to show you how to do this because there's a shortcut to this, and all you have to do is go into that download folder, unzip, and then click on Circuit 1. It'll bring up the program. So if you actually went in and downloaded that, you can click on Circuit 1, and it pops up. This is from the downloaded file. It'll actually bring this file for you opened. And let me just zoom in so you can kind of see it. It's here, and it's loaded. Now, if you look at this carefully and try to study this, there's a lot of instruction they give, but one thing that they did really well was they give a lot of documentation. Good programmers try to explain to other programmers what they were trying to do on this program. So there's a lot of these instruction codes, and then when you get towards the bottom of this, there's actual things like output 13, digital pin output 13, and then they talk about some loops and stuff like that. I can't explain the subtleties of all these little codes, but what we will do is go into lesson 1, and I'll let you guys manipulate some of the variables, set up your breadboard, plug in some wiring, the LED bulbs that you'll need. If you open up your kit, if you just give me your eyes over here, inside of your kit there's 2 sides. One side has all of the electronics pieces, and on the back side is a nice little holster for your book. So open up that book. And you'll notice that this has like all of the lessons, lesson 1 through 16. I would love to see people working together on lesson 1. If you moved ahead and you figure it out, then talk to the person next to you, bring them along with you so they have a good understanding of how this works. Now that you have your lesson or your program loaded here, we can upload it to the breadboard, but it won't do anything until we've actually set up our wiring. So let's go ahead and make our first program on this. And I'm on page, tell me what page it's on, please, class, looking at the page number. Where does lesson number 1 start? Page 18. Okay, so I'm going to go to page 18. She's saying that it's 18.
On the book anyway.
Yes, on the book. We're looking at the book. Perfect. So lesson number 1 begins on page 18. Now, I guess as I get older, I find that some of the writing is a little bit hard to read as it gets smaller. So what I did was I actually uploaded or downloaded, it's on the Google Classroom, it's a link to the online guide. It's a PDF. And the nice thing about PDF is that you can magnify it and the ratio still stays. So if you would like to use this book in a digital document or share it with kids so they can look at it, then it's on the Google Classroom. I would recommend you guys go and open that as well. So you don't need your computer really for anything else other than to either access this guide or to then, when we finish building the circuit, to upload the program onto your breadboard or to your Redboard, your Arduino board, and then we'll actually see if it works. So it's easy for me to check for understanding on this because if I walk by and I see an LED blinking at a certain rate and I ask you how do you change that and you know how, then that means you finished lesson 1 and you go on to lesson 2. But please teach some people around you as well. Let's make sure that we make this collaborative so that everyone is on the same page when you guys go on to the next lesson. So please try and start with page 18, lesson 1, and let's see where we can go from there.
But is this what I'm looking for? Did you
Turns on the
Instead of doing the library the way I was able
each
to do
one
it,
one at a time.
just load it one at a time, and if you don't do number 1 all the way, then you don't have to. Because we put that in your library. You and I actually put it in there, but no one else, and I don't want to try and do that for everybody. But yes.
With 30 kids.
All they're doing on the computer is the computer that's working. And just plug yours in and let them upload it to yours.
Oh, okay, and then black with
One more actually. Yeah, it is. Like, so look, they removed the cover on the backside, and what this is really. This has 5 volts of power going through it, so I have to lessen the amount of energy that's going into it, because I don't want. If I put too much on there, it'll blow it out like a Christmas tree light. It'll blow it out. So.
That's what that is, right? Slows down. Wait for 1 second, basically. Change it to 3.
You'll need the shield connected, so check with your neighbors, make sure their shield is connected. There's only one way that it goes on, so if you have it backwards, it won't register or the light won't turn on. There should be a blue LED that lights up at the top. If you have it backwards, the power plug won't send power to that little LED. So you'll know it's working if you see the little blue LED. Show it to the neighbor next to you that's still not there and let them make sure that they have it set up properly. There's also a soil moisture sensor tucked into your blue box somewhere. It just looks like a tiny fork, 2 little black tines on it that we'll use as a soil moisture sensor. And I'll give you a little bit more of the information on that once you have that. For those of you guys that have all that and you're kind of waiting for everyone else, there is this, this sensor shield hookup guide that's inside of Google Classroom, SKMP, the stream. And it has a file that we have to download. We need to be able to communicate with the Shield and the Arduino. The same way that you guys downloaded the software to communicate, the FTDI software, that driver communicates with your Arduino and the computer. Well, now we need to be able to say that little thing that I connected to the top of my Arduino, we have to be able to have open line of communication. And that's going to be the, it's called a analog auto ID zip file. And the beauty of this is that you don't need to tell Arduino what type of sensor it is. You don't need to tell Arduino anything else. If you plug a sensor in, Arduino will recognize what type of sensor it is. Someone programmed, someone stayed up late at night figuring out how to make sure that you don't have to do this. So the benefit of those people, right? That's why we pay them the big bucks. Some kid making $150,000 a year. Hopefully it's one of your students. Right? Okay, so I have to download the auto ID zip file. So when I go back into the classroom, I see that there is the Vernier Analog Auto ID zip file. This is the download file. You don't need to go online or anything. It's just there. But if you don't have access to Google Classroom, you can just do a Google search and look for Vernier Analog Auto ID zip. It'll take you to sparkfun.com, and you can find this file on SparkFun. But my recommendation is just go into the Google Classroom. Let me zoom out so you can actually see. Under the stream, I just went under the SparkFun SICK help files. And then I'm looking at the Vernier Analog Auto ID zip. So if I click it, what should happen is some kind of download should happen. So here's this. Now, do you see the download capability? So let's go ahead and download it. Voila. So I have this downloaded, and I want to install. Now, this might be where it's going to be a little tricky. So I'm going to call in a few of my local experts here to just kind of help people make sure that they install this into the proper document. So I'll try and go over this online, but my Mac may not be the same operating system as your Windows. That's a definite no. So you'll have to possibly do this a little differently than I did. So it's there, it's been downloaded. It's under my download folder, right? So we're going to have to search for this file in a minute once I'm into the Arduino IDE environment, the programming environment. So I'm going to have to search for this and load it onto Arduino. So what I'll do is once it's been downloaded, I've noticed it's completely downloaded. I'm going to just go out of this, close down or minimize your internet browser, load your Arduino, and then I'm going to go and find out how I can add this library to my computer. So what I want to be able to do is I want to be able to look at this and go under like the sketches or the examples and find where my Arduino auto ID is. So mine has already been loaded, but this is like success, right? So this is how I know you did it the right way. If you go into your computer and you're able to find Vernier Analog Auto ID, so I should be able to click on it and it will load the program Vernier Auto ID, you know, whatever, right here. So now I'm going to upload this. That's the final product. I'm giving a couple steps in advance. What I want you to do right now is just go through the steps on how do I load this onto the computer. So if you go under like Tools, maybe I'm going to look at File. It's under Sketch. I apologize. It's under Sketch. And if you do the Add File or Import, I think it's Add File. So again, I'll just close this up and do it one more time. File. And then I'm going to just move over to Sketch. And then you'll see that there's this Add File, Import Library. And I think it might be, I think it's under Add Library. So it's Import or Add File. But I'm going to say try both. One of them will work for sure, I promise you. Import library is where I'm going to just go and just walk through the use with this. I'll troubleshoot with you. So if I add library here, it should pull up a okay, so here's all of the folders where I can download my zip file to, right? So that, remember I downloaded a zip file a minute ago? Where did my zip file go? What folder is that found in? The downloads, because I just downloaded it. I'm going to go and find my downloads. And I'm just going to search through all these files until I see my Vernier Auto ID. Did I pass it up? OK, so it should be at the bottom because it's Vernier with the V. And then I'm not going to click on the Auto ID. I'm going to click on the zip file because I need to upload the zip. And then you should see it. It doesn't give you an option. If you click somewhere else over here, this choose cancels out. So if you click on this Vernier zip and then hit choose, it should load that library for you. So mine says it already exists. But tell me if yours works. If you did, give me some feedback, please. A thumb up says, I just ran this and it worked. Thumbs down, I need some additional work on this. It's not working. What was the comment that it told you?
It didn't work like it.
Yeah. What is yours? Did yours give you a message on the bottom of yours?
When you go to Sketch and you go to Add File, it doesn't have that arrow.
OK, so do the import library first.
I don't
Okay, so you don't have an import library section? Okay, so then you possibly can do then in one of these, maybe Sketchbook and libraries, and then maybe it should, or there, you know, so different programming, so like on Windows, they're in different locations. So that's why I'm saying you're going to look to find a way to go to Sketch and then try the add files or import library. That's what my message is in for Mac. So one way or the other, try to find a way to add a file or import a library and then go into your downloads and do that. I'm going to just send a couple people walking around and we'll try to help people. If you can get this in the next 5-10 minutes, then we can show you how to use this Vernier product really quickly. I put a bunch of dirt into this, and then I put water in, a certain amount of water. And what you want to do is, these sensors work well enough if you put them in the ground like a fork, but because you're going through different levels, what it really does is digitally, it just checks the amount of resistance. Like in a circuit, it checks the amount of resistance. That's how this moisture works. What you should do, though, is horizontally plug it in, because then it's taking that same layer of moisture at that layer. So what the prescription, or in the instructions, what it says is to do is to, if you're going to do a sample in a cup, cut a hole in the side of the cup and then just kind of plug it into the side of the cup. So this dirt, what I would like you to do is do a dry run, and there's not enough cups for everybody, but get some dirt in a cup, fill it about halfway, and then run it through dry, and then I'll show you how you can actually look at the data from there, and then add some water into it, swash it around a little bit, and then run it through again. So you may need to cut it with a box cutter, just put a little sliver on there, so that way you don't bend your tines on your sensor. But if you get maybe 1 or 2 cups, and then like let everybody kind of just use those, do a dry, and then we'll put water, and then we'll show you what the difference is and how it measures. I'll try to give you that in 5 minutes. So here's some cups. If you have a paper cup or something, or like a cup that's used for lunch, you're welcome to use that even, but there's some dirt over here. I brought dirt for y'all. So now, if you upload this program, just let it install the driver.
Should I make it bigger? Oh, there it goes. There.
And the way that, and like we were talking about consistent results, the same thing is when you look at that serial port, you can actually copy paste those Excel, you know, and then you can look at those and get an average of your sensor readings. Yeah, so I wanted to kind of give you guys the primer, just the beginning of this. What I would hope is that you go in and look a little bit more on the lesson plan book itself, because what's going to be the value of this is when you come back and say, hey, look at what I've tried here, or I have trouble with this, that when we can have more meaningful conversations. So I'm hoping to come back and give you a much more intricate side of how to program with the Arduino and using sensors to use programming so we can create triggers with those sensors, which is the real value is what I think.